WATF team. Thanks. So I just want to give the floor to Sarah just for her to introduce herself.
Thanks, Emily. Sarah Brucker, an Assistant State Engineer with the Division of Water Resources, taking over Tracy Kozlov's former role. I was involved with the WATF probably 5 to 10 years ago, so it's nice to be back in this realm. I always enjoyed getting the updates from the state climatologist and hearing what's going on around the state. So glad to be involved with your group again.
Awesome. Thanks, Sarah. Okay, so if you all didn't see the agenda, we're going to have our normal presentations from CSU and NRCS, and then report outs, and then I'll be giving a really brief presentation at the end, explaining a little bit more about the WATF rebrand to Water Conditions Monitoring Committee. So make sure, if you can't stay to the end, maybe I'll send out some slides or some more info, but yeah, if you want to stay to the end to hear more about that, I'll be giving a presentation. So shall we start with CSU? Becky, I made you co-host, so I think you can share your screen.
Okay. Make sure that look good.
Yeah.
Great. Okay. Thanks for having us on again to present on current climate conditions, and thanks everyone for joining. I will go ahead and get started. So our November meeting is always a little bit different, where we kind of talk about what happened with the water year, the previous water year that ended, and then give a kickoff to, what we've seen with the start of the next water year. So I'm first going to be doing a recap of water year 2023, which was October 1st, 2022 through September 30th, 2023. And then after that, I'll go more into what we're seeing with current conditions in this water year. So here we're looking at a map of precipitation for the entire water year, and the colors depict the ranking of how relatively wet or dry ranked the water year was compared to the 128-year record from the NOAA data set. So where you see the greens are areas that ranked in those wetter categories, and where you see the browns are where precipitation ranked in the drier category. So if we took an entire statewide average, out of the 128-year record, this water year ranked as the 31st wettest. So definitely on the wetter side of things, almost 2 inches above the 20th century average. And focusing in on the map, you can see where we had, if you look at the water year in its entirety, you can see where those wetter conditions are on the west slope. And then particularly if you look around the Denver metro area and east onto the plains, that darkest green color is record wettest. So out of that 128-year record, water year 2023 takes the gold medal. And then where we had the dry conditions show up over areas in southern Colorado, particularly around the San Luis Valley and Sangre de Cristos, where we had a couple of spots that ranked in the bottom 20th of the driest of those 128 years. So on the left, we're looking at that rank again for the statewide, but now we're just looking at kind of the whole contiguous United States to see kind of where we pair up with that. So again, the 31st wettest is the 98th driest, which is what shows up the rank on there. But the blues show the states that ranked wetter, and the browns show states that ranked drier, so you can see how we compared. And then on the right-hand side is the table that shows the month-by-month breakdown. And we had a couple of months that were overall dry for the state, being April and July. But for the most part, we had a lot of near average months, and then a couple of wetter months that really got us to that 31st wettest. Finally, this is a look at what the water year precipitation looks like over time in that 128-year record. So we take that statewide precipitation total, the long-term average, the most recent 30-year average says that our statewide average precipitation should be around 18 inches. And you can see what we've seen over the 128 water years. If you look at the last dot on the right, that shows that almost 2-inch surplus that we experienced in the most recent water year. And this is following 3 drier water years. So definitely nice to have that relief. You can see, particularly if you focus in on the 21st century, that we do get some wetter water years, but not to the level of wet that we've had in the historic record. And we've had a lot more frequent of those drier years. So we're going to shift and talk about temperature and what we saw for water year 2023. The map on the right, it's actually a pretty boring map. There's a lot of white, which is actually kind of surprising because we've had a lot of years recently where we see a lot more red, and that would be the warmer rank. So when we take the rank out of the 128 years, you can do it one way or the other. It was either the 60th warmest or the 69th coldest. So kind of right there in the middle, very close to that 20th century average. And you'll see later, but when we look at our most recent long-term average that we calculate for 1991 to 2020, it's actually cooler than average. But when you look at the 20th century as a whole, then it's a little bit closer to what we typically experienced then. So we have some cooler pockets and some warmer pockets, and some of those line up to where we had the wetter conditions, cooler and wetter in the northeast part of the state, and where we've had drier conditions, a bit warmer there in southern Colorado, but overall pretty close to average for the water year. Again, looking at that statewide average temperature rank, and while we were pretty in the middle of the road in terms of temperature, there were a lot of states that ranked very warm, and we ended the water year extremely warm for the globe as well. So we were a little bit of a cool pocket compared to what you would see globally. And you can see that there are a few states there, Louisiana, Florida, and Maine, that this was their warmest water year on record. The table on the right shows how those ranks played out by month. So prior to the summer, we really only had 1 month that ranked warmer, and all of the other months were either near average or cooler. And if it weren't for the end of the water year, our rank would have actually been a lot cooler. But we did end the water year with some of those warm anomalies, particularly August. This is not something you're going to commonly see, where I can count 5 months in the water year that were in that cooler than average category. That just doesn't happen that often anymore within our climate warming signal. So here's that water year temperature over time for the statewide average. And if you just kind of look at this whole graph, you will notice that general warming trend that we've been observing over the state. Again, that solid black line is showing that most recent 30-year average. And so if you're not looking at the 20th century average, but our most recent average, now you'll notice that the last dot to the right shows up as a lot cooler than average. So that dot looks really low, much more indicative of what we would have seen in 20th century temperatures, but not as common when we look in the 21st century records so far. So you can see that temperatures have not been this cool since, I think that might be 2009 showing up on there. So quite an anomalous year for us, even though it shows up as kind of middle of the road normal when you look at the historic record. So another graphic we put together at the end of the water year is we look at a month-by-month breakdown of the daily records that were broken around the state. So for each month, you can see the two columns on the left, the high max T and the high min T are when you've broken a record high or your low temperature has been warm, like record warm. And then the blue columns to the right of that are if you've broken a record low or your high temperature was record cold. So we've got warm records versus cold records. Typically, when we are looking at a water year and we add all those up, we've been seeing about double to 3 times the number of warm records compared to cold records. So again, this may not be surprising to you to see that there are more warm records than cold records, but the interesting story here is that there's actually not as many warm records as we've seen before in previous water years. When we're talking about in our warming climate, we're breaking a lot more warm records than cold records, but this year is the exception. And then you can see it's not uncommon that we will continue to break precipitation and snowfall records, which we did throughout the water year. So we have a much longer water year summary, and if you scan that QR code or go to the link that's at the bottom, or once Emily shares these slides, you'll be able to visit that and see you can get a much longer summary with a lot more stats and a look at some of the significant events that happened in water year 2023. And now I'm going to go ahead and dive into what we've seen so far for water year 2024. So here's our temperature rank map, just looking at October. And it's been a bit of a different story already where we're seeing a lot more of those warmer ranks. So particularly in southern Colorado and across western Colorado, we've seen warmer ranked temperatures down in the southern part around Durango in the San Luis Valley. We're looking at a top 10 ranked warmest October in the record. And then everywhere where we see white, so going out east towards a lot of the areas of the plains and the Front Range Urban Corridor, we ranked kind of in the middle. So the statewide ranking for October 2023 was the 26th warmest October in the record. And then looking at precipitation, we were a little bit drier if you do the whole statewide average. So the rank was 53rd driest. So kind of middle of the road, but leaning a little bit drier. Again, where you see the whites, kind of in that middle of the road. Where we have greens, there around Eagle County and Pitkin County, we're seeing those wetter ranks. And that was really from just a one or two storms. And so it's kind of giving that little bit false sense that conditions have been good there. But it really only happened in a couple of storms and didn't really stick around. I'm sure we'll see this. We could see this from Brian's presentation. But that's where we've had our wettest pocket. And then where we've seen drier is across southern Colorado, across the Sangre de Cristos, and into southeast Colorado, where we've been ranked in that drier, those drier categories. As for temperatures, this is looking at the last 30 days. So what have we seen for basically all of November compared to the most recent average of the 1991 to 2020 mean. So where we have those reds, it has been warmer than average. We've had pockets, particularly around the Front Range urban corridor, in Northwest Colorado, down around the San Juan Mountains and San Luis Valley. And then where we have those blues are areas where it's been a bit cooler than average. So around South Park, the I-70 corridor mountains, and a little bit on the plains. Here's the precipitation that we have seen so far for the month of November. This goes through Sunday morning. So as you can see, we've had very little accumulations from November 1st to November 26th, very little accumulation out on the Southeast Plains. Northeast corner has gotten a little bit more. The mountains have gotten anywhere between a half an inch to an inch and a half. Which seems pretty decent until you look at this as what they would typically get in November. And so I'm going to switch over to this map, which shows that same time period, November 1st through November 26th. And what was the precipitation compared to what is normal for this time of year? So the browns are drier, below average. And no surprise that the southeastern plains are showing up with much below average precipitation conditions. That northeast corner where they've gotten about a half an inch, that shows up as a positive anomaly. Once we go west of the divide, that precipitation is not keeping up with average in most places. And that's because once we get to November, we really start ramping up the precipitation that we want to normally see in the higher elevations. And so even though we've been seeing moisture, it's not been quite enough to keep up with average. We do have a little bit of a pocket here, Grand Junction and West showing up with above average, and around South Park showing up a little bit above average. But overall, November has continued the below average precipitation anomalies. Because of the drier conditions that we've seen, we're starting to see this manifest in the soil moisture. So on the left is the map of the shallow surface soil moisture, and then the map on the right is a deeper profile going down 1 meter into the soils. And so we're seeing those drying soils throughout a lot of Western Colorado and popping up on the Eastern Plains as well, primarily due to short-term dryness on the Eastern Plains, a little bit longer-term dryness when we're talking about Southern Colorado. So evaporative demand is not something we are typically talking about in November, but it's a good indicator of possibly other conditions that might be driving the dryness in the area. So evaporative demand is going to combine your temperature anomalies, your wind, the amount of sunshine you're getting, and the humidity of the air. And so where we see those dry category colors means that evaporative demand is higher than it normally would be this time of year. And so what that typically means is we could be melting snow instead of holding on to that snow. Areas where there aren't snow, the vegetation is drying out faster. In general, just drier conditions, which we see this is extending out for 2 months. So basically back to late September, overall, we've been seeing drier air around the region. And then this is looking at a vegetation product. This one is called Quick Dry. And so it's a little bit of a shorter term product compared to Veg Dry, which is longer term. Veg Dry is largely going out of season. This one is also quickly going out of season, but we can see from that quick snapshot that pretty much all of Western Colorado is showing up, the vegetation showing a bit drier than what we want to see for this time of year. So the next few maps that I show are focused in on the standardized precipitation index. So that's taking precipitation for a specific time period and looking at how anomalously wet or dry that precipitation is for that time scale. So this example is looking at 60 days. So this is a short-term SPI. And where we have those warm colors lines up with drought categories. So the yellow would be equivalent to D0, down to the maroon, which would be equivalent to that D4 category, just for precipitation anomalies. And then if you see the greens, the blues, the purples, those are wetter anomalies, and the gray is showing up right in that near normal range. So looking at our short-term SPI for the last 60 days, we're seeing a lot of dry SPIs popping up, particularly across southern Colorado, the Southeast Plains, around the Front Range, and into the northern mountains. Overall, we're seeing a lot of dry conditions, and then the grays show where we're seeing a lot of those near normal precipitation conditions for the last 60 days. Extending this out to 6 months, so this is a longer time scale. So we're more talking about long-term drought or long-term wetness. We start to see that divide between eastern Colorado and western Colorado. So as you go east of the divide in northern Colorado, you can see a lot of those greens, blues, purples. So extending that SPI back to late May, we're seeing those very wet conditions that we experienced throughout the summer popping up over a lot of the plains. And this is also good to show that the dryness that we've been experiencing through a lot of western Colorado, we can now start to call that a little bit more of a long-term drought situation. This isn't just short-term. We're getting into that longer term. So as we look on the west slope, down into the San Juan Mountains, down into the San Luis Valley and Sangre de Cristos, where we're seeing a lot of those really dry SPIs on that longer time scale. One more as I extended out over an entire year. So this is going back to November 27th of last year. And for the most part, you can see a lot of those dry SPIs disappear, which really is a note to how wet the winter was last year, over the mountains. And the areas that the area that really sticks out to me here is, again, the San Luis Valley, which still shows up with dry categories, even when you extend out to a 1-year SPI. So that's given us kind of a hint of where we're going to be looking at drought. So the first map I'm showing is the drought depiction for the lower 48 states. This was as of last Thursday. It will be updated this week. You can see where the droughts are primarily over areas in New Mexico. We've got drought in the Southeast United States, focused over Louisiana, a little bit over the Corn Belt. And we don't look relatively too bad when you compare to some of those spots, but we will zoom in and see what's going on specific here. So same map, but just focused in on Colorado. We're looking at about 27% of the state is in a drought category. So the drought categories are D1 moderate drought through D4 exceptional drought. We do not have any D4. We have recently introduced D3 into, big surprise, the San Luis Valley. And we do have as well some D2 pockets around that D3, also around the Dolores River Basin and towards the Colorado River Basin around Grand Junction. Areas that are drought free are where we see those wetter conditions that have the memory of them kind of still remain, even though we've been drying out recently. And these are how the drought conditions have changed since the beginning of the water year. So where you see greens are areas that experienced improvement. So recall when I talked about the October little bit of wet anomaly coincides to a little bit of improvement we made back in October in drought conditions. But aside from that, we've mostly seen drought degradation throughout the state. We've seen drought conditions expand in parts of eastern Colorado and all throughout western Colorado. And the darker, there's the yellow and there's an orange, and that light orange is a 2-class degradation. So we've seen a higher magnitude of drought degradation in those areas. All right, last little bit here is we're going to switch and talk about the outlook and what we can expect as we go forward. So we have our 7-day products that we regularly share. So this is, this is from yesterday. I didn't update it this morning, but overall we're seeing a pretty dry pattern. There is going to be some precipitation over the higher elevations. If you look on the map on the right side, that's showing it as a comparison to average. So we can see that the San Juan Mountains expect to get a little bit above average precipitation for the week. And then where we see the browns, the precipitation is going to be not quite keeping up with average, or where you can see we're just not getting precipitation. So of course that's going to be below average. Climate Prediction Center has their 8 to 14 day outlook that goes to early December. So the map on the left shows the likelihood of temperatures being above average, below average, or near normal. The map on the right is for precipitation. So on the left, we see that most of the country is looking at an increased chance of above average temperatures. Colorado is included in that, particularly if you go over the eastern plains. There's high confidence in those above average temperatures to start out the month of December. On the right, precipitation likelihood of above or below or near normal precipitation. The browns are areas where there's an increased likelihood of below average precipitation. So a lot of the state, northwestern corner of the state looks to be near normal. The light brown, that's a very slight leaning, but once we get into that slightly darker brown color, that's a little bit more confidence in below average precipitation for the southern part of the state. And then this is looking at the seasonal temperature and precipitation outlook from the Climate Prediction Center. So we're looking at the December, January, February time period. And this was released mid-month November on November 16th. And so the temperature one is pretty interesting. First, you can see that almost the entire northern portion of the country is expected to see above average temperatures. The white means equal chances, so there's not really any certainty about what temperatures will do. And then we have this gray over us, which shows that we're more likely to have near normal temperature conditions for the winter. Now, this is comparing to that 1991 to 2020 average, which means this would typically be warmer than the 20th century winter, but much more seasonal compared to what we've recently been seeing. And just to give you an idea, our winters have actually been pretty seasonal. That's where we've seen probably the least amount of warming in the recent years. We've had quite a few Februaries that have been below normal. And so basically, I take this to mean that we can expect a pretty seasonal winter in terms of temperature. So we're going to have those colder temperatures dominating, with a few warmer snaps in there, probably a couple of really cold snaps. If we look at the precipitation on the right, this is partially a precipitation pattern that is driven by the El Nino, where there's a high confidence that the southeastern portion of the United States will have above average precipitation. It's very typical for an El Nino. Also, the southwestern part of the country tends to be wetter in an El Nino, and then drier conditions up north and around the Great Lakes. We are showing up in a very slight leaning of wetter than average, but I would take that with a grain of salt. It could go either way, but they are seeing that it's slight leaning for wetter than average conditions for us for the winter. So I mentioned El Nino, and this is a close look at the El Nino forecast. So on the left, we're looking at what is the probability that each 3-month period will be in an El Nino, which would be a red bar, a La Nina would be a blue bar, and the gray bar would be neutral conditions. And so we're looking at those ocean temperatures in the tropical Pacific, and what is the likelihood that we'll stay in the El Nino. The red bar is that basically there's 100% likelihood we are staying in the El Nino that we are currently in, at least into the beginning of the spring. And then if you look at that MAM, that's March, April, May, the probabilities of El Nino still high, but start to drop. And then the gray bars start to increase, showing that by the time we get to summer, there's a good chance that we'll be into neutral conditions. So the graph on the right shows something very similar. It shows what all those models are showing. So the sea surface temperature anomalies when you're in an El Nino are going to be above the 0.5. And so you can see starting October where that black line shows we're well above 0.5. So we're in a strong El Nino right now. And then the plume of lines shows what the forecast of those sea surface temperatures are going to be. And so you can see that they peak out around a 2-degree anomaly, ranging anywhere, all the models ranging from a 1.5 degrees up to 2.5 degrees anomaly through the winter. And then all the models start trending downwards towards more near normal SST anomalies, which would be that neutral category. So most of the models are pretty confident in this, that we're going to be an El Nino for the winter. The El Nino will weaken through the spring and go towards neutral conditions in the summer. And what does the El Nino mean for us? This is a graphic that will be in our upcoming Climate Change in Colorado report that shows the general relationships between El Nino, La Nina, and precipitation around our state. So if you look at the top left corner map, that's the December, January, February. We're looking at, we see that blue over the northern central mountains, and that's an area that tends to be wetter during a La Nina and tends to be drier during an El Nino. So if we see areas that dry out because of the El Nino, we would expect to see that over the northern and central mountains. If you look at all the other months, we see a lot of reds, and those are areas that tend to be wetter in an El Nino. But for example, if you look at the lower right-hand corner, that's September, October, November, which shows that the majority of the state tends to be wetter during an El Nino. And that's not something we've actually seen this fall, which is just that reminder that this is not a perfect relationship. This is another guide that I like to share that really that shows what the snow pattern tends to be during an El Nino. So if you look at that's the 10 strongest El Nino events, and we know we're in a strong El Nino. So this is kind of the one we would want to look at. And what were the snow anomalies when we look at those El Nino winters? And if you focus in on Colorado, you'll see those northern mountains, northern and central mountains pop up with that dry spot. So typically during a strong El Nino winter, we see less snow in those northern and central mountains. But throughout southern Colorado and across the eastern plains, we tend to see more snow during an El Nino winter. All right, so just key takeaways from the presentation here. From the current conditions, we finished the last water year 2023, in a cooler, wetter type category, generally speaking for the state. But water year 2024 has started out warmer and drier. We've seen drought conditions expand, and given the current conditions that we see when we're looking at soil moisture, vegetation, precipitation patterns, I would expect to see more drought expansion in the coming weeks. As far as El Nino, it does favor the southern mountains. So if we have drought recovery, I would hope it would be over that area. But there could be more drought expansion in the cards for the northern mountains. And then, of course, the reminder that that relationship is never perfect. Given our winter outlook, I would say expect our winter to have snowy conditions at times and some cold snaps. That's, I think, all that I have for you.
Thank you, Becky. Thanks for being here. Anybody have questions for her? All right. Well, seeing none, I think we can move on to NRCS. Brian, I also give you co-hosting options, so I think you can share your screen. Again, thank you so much, Becky. Great presentation.
Thank you.
Yeah, thanks, Emily. And yep, thank you, Becky. Let me share my screen here. Get the presentation going. I think I should be able to share. A little sneak peek there. Can you guys see my screen? Yep.
I cannot yet.
Okay. Here we go. All right, and you should be able to see the presentation here shortly. Taking a second to load. Oh, okay. Can you see the presenter screen, or can you see the main screen?
I see a tab with the Zoom link.
Okay. Sorry.
No worries.
Get this on the right screen here. All right, I think I have it now.
Yes, that's it.
Perfect. Alrighty. Well, hello again, everybody. Thank you for having me back to the WATF. It's been a while, and I'm really appreciative for Carl and all his help. But I'm going to go ahead and jump right in here into the presentation. So starting off in the northwest corner of the state, over there in the Yampa and White basins. Yeah, you know, Becky really kind of covered it. Right now, we're looking at a lackluster snowpack, largely across the entire state, and maybe lackluster is maybe a good way to put it, especially here in the combined Yampa White basins. Snowpack in the combined Yampa White basins is the lowest of the state, but you know what I'm showing here is those sub basins within the Yampa and White basins, and we're just looking at a snowpack that's slightly above half of normal, if not a little bit lower than that in some locations. And then looking at the trace of what we've had since the beginning of the water year in terms of snowpack accumulation. Water year starts on October 1st. We had a storm that gave us a little bit of snow and then melted off. That's relatively normal in Colorado. And then by about November 1st is where snowpack usually starts to accumulate and build up and not really melt off. We had a little bit of melt, you can see here, but not too much. So we had this kind of second storm. And then after that, in the northwest corner of the state, we had another little storm with a little bit of accumulation, but you can see the deficit here that we have between where we're at right now in the black line and where normal or median is here. We're about 1.5 to 2 inches short of normal snowpack, and that's in snow water equivalent. Precipitation is a little bit better, but not great. You can see that we're out of that bottom 10th percentile, thankfully, but not much better. A little bit closer to normal, and you can see here that precipitation in the combined Yampa and White basins is 73% of normal since the beginning of the water year. Moving on over into the North Platte and the Laramie River basins, again, snowpack is not very good, just above 55% of normal. And there's room to grow there for sure. Again, same kind of situation as in the combined Yampa White. We're looking at the bottom 10th percentile for snowpack at this point. We've had 3 storms really, one longer storm that kind of produced some snow over the course of a few days. But since then, we've had a little bit of accumulation, if any at all. So not too much there. In terms of precipitation, again, we're looking about that bottom 10th percentile. Snow or precipitation since the beginning of the water year in the combined Laramie and North Platte basins is 62% of normal. Reservoir storage is slightly above normal here. You can see at Yamcolo, we're looking at about 112% of normal, and then Stagecoach is right at normal. And then looking at reservoir storage for the combined two reservoirs there in that basin compared to the rest of the history or the time series here. Again, like I said, reservoir storage is near about normal. So here we're looking at, this is the stream flow as a percent of normal in the combined Yampa White. 91% of normal. You can see that there's actually kind of a diversity of the various stream gauges within that larger basin. Some of the upper gauges are reporting lower, well below normal stream flows, whereas you go a little bit further to the west downstream and stream flows are a bit better, but really nothing to write home about. So the upper end of the basin being as dry as it is not a good spot to be in. We'd like to see those flows near to above normal this time of year. With us going into winter, what happens is when you go into winter here, as the snowpack falls and accumulates, and you kind of seal that soil moisture in until things melt off in the spring. We kind of seal in those lower than normal soil moisture conditions, particularly those that Becky was talking about earlier. And that's also reflected in these stream flow observations. So it's unfortunate that we're below normal for stream flow and soil moisture conditions, but hopefully we'll get above normal snowpack and we'll see those soil moisture conditions recharged when snow begins to melt in the spring. Moving southward into the Colorado, the headwaters of the Colorado River Basin. Sorry, it's a little bit hard to make out here the graphic that I used here. So the Colorado River Basin is encompassed by this area here that I'm kind of tracing out, or hopefully you know what that area is off the top of your head. But I just wanted to provide a more finite representation of what's going on within the Colorado River Basin. And here again, snowpack in the upper part of the basin, the upper reaches is below normal. You know, we're looking at anywhere from a high of 70 to 75% of normal to as low as 35% of normal, and that's kind of, or 27% of normal, excuse me, and that's right next to, you know, those basins are kind of right next to one another there on the northern end. On the southern end, you know, in the Roaring Fork, things are looking a little bit better. Becky did point out kind of that wetter spot that existed in kind of the central part of Colorado, and that is here in the Roaring Fork, the headwaters of the Roaring Fork. And we'll also see that in another graphic or two down the road here in the presentation. But really, you know, looking at a very small area of influence from that target, so to speak, or that targeted precipitation that we received. And honestly, I would say that even that is waning as we continue to dry out and just not see a whole lot of precipitation. You know, North Lost Trail is showing 150% of normal snowpack, and Kiln is showing above normal snowpack there too. But really, we're only talking about a few sites that are having a bit of an influence on that, just the Roaring Fork itself. But again, you know, this is certainly not out of normal to see just a few sites that are above normal. So hopefully we'll see more widespread precipitation coming up here. Looking at the trace of how snowpack has performed over the course of the water year, again, we got that storm pretty much melted off, and then we got another storm there at the end of November, or excuse me, the end of October. Saw an improvement from that, but after that, again, lackluster. We've had below normal snowpack accumulation since the end of October, and it's really underperformed to this point. Snowpack is 69% of normal in the overall Colorado headwaters basin. Precipitation, on the other hand, we did receive a bit of precipitation earlier on in October that has helped out. But again, you know, since the end of October, things have been relatively dry. We'd like to see some more precipitation. However, overall, kind of a bit better across the state. As you compare to other basins in the state, the Colorado headwaters is 85% of normal for year-to-date precipitation. Reservoir storage and the combined, from the individual reservoirs across the Colorado headwaters looks relatively normal, with the exception of Willow Creek Reservoir. The others are near just slightly above normal. And you can see that on the whole, we're slightly above normal there here comparing to the trace time series. Stream flow in the upper headwaters of the Colorado overall is 116% of normal. That is pretty good comparatively across the rest of the state, with the upper portions of the basin showing better stream flows. So we're still having some residual runoff, or I should say soil moisture is still pretty good. And that's where the runoff is kind of coming from, is that soil moisture that we built up from the good snowpack and the runoff that we had. But again, I think that is beginning to wane a bit, as dry as things were this summer. It's kind of negating the effects of that above normal snowpack that we saw. Moving eastward into the South Platte River Basin, snowpack here too, not doing so hot. I think a lot of the accumulations that we saw from this more recent storm was lower elevation. We really didn't see the bump in snowpack that we would have liked to have seen in the upper reaches of the basin. So going all the way into the headwaters of the South Platte, or honestly, when I'm talking about upper reaches, we're just talking about the upper elevations as well. In this case, just really not seeing great snowpack. Looking at the trace of snowpack since the beginning of the year, again, same thing, lackluster November so far. Of course, we're just about to round out November, so I don't see much of a chance of improvement. I don't even think there's much of a chance of precipitation, as Becky mentioned, for the rest of November here. I think maybe one of those storms is supposed to be later here in the waning days of November. Snowpack in the South Platte is 59% of normal. And hopefully we'll see a boost here relatively soon, if not in the spring. And then precipitation again, near about the 10th percentile at 62% of normal, or 62% of median. I should be more specific when I say normal, median in the South Platte. Looking at all of the reservoirs across the basin, they do vary a bit more than the other basins that we've looked at. But we are a bit above normal in the South Platte combined for all the reservoirs together. So that is a positive, again, building on the strong snowpack that we had last year. Or yeah, let's call it last year, in terms of we are in the 2024 water year now, so I can say last year in that case. Stream flows, not as good as in the Colorado headwaters here in the South Platte, looking at 84% of normal. And you can see some of those individual stream flows. We don't have very much data here. We're lacking some of that data. I'm not exactly sure why. It might be frozen gauges or just a little bit behind on getting that data in. But in the northern and the southern or the upper headwaters of the South Platte, we're lacking data, but there in the central part of the basin, we are showing some data points there to lend to that 84% of normal. Moving into the Gunnison River Basin, things are a bit kind of stratified here in the Gunnison. So you look at the western portion of the Grand Mesa, we're seeing some okay snowpack observations there, and then Columbine Pass is showing some pretty good data there. But other than that, looking into the San Juans as it feeds the Uncompahgre and even the headwaters of the South Fork of the Gunnison, really not showing some great data there. I mean, Park Cone and Butte are showing 100% of normal. Schofield, unfortunately, is at 78% of normal. Schofield usually holds a lot of snow there. Upper Taylor's doing okay, but otherwise we're not showing, great information there. Or I shouldn't say great information. We're not seeing great data. If we're being driven by Columbine Pass and Mesa Lakes, those do well. Let's say Mesa Lakes holds a fair amount of snow. Columbine Pass doesn't usually hold too much, especially this time of year. So really not great numbers, but the Gunnison does have the highest snowpack in the state at 79% of normal. So I guess there's a little bit of something to write home about there, but not too much. Still being below normal. At least we're not in the 10th percentile like we are with some of our other basins there. Into precipitation, a little bit better outlook, 86% of normal as it stands right now in the Gunnison River Basin for year-to-date precipitation. And then looking at the reservoirs, statewide. It is rather near normal. Fruitland Reservoir, I performed a quick check on this data, and it does seem to be valid. On Fruitland, I'm not sure why it's running quite so high. I believe because this time of year, the relatively low average values, when you actually pile on some really high observed values on top of the average values, naturally you get some very high numbers. So we think that's what's driving that high number there. Oh, sorry, it looks like I neglected to add in the, oh, there it is. I have it out of order. Forgive me. Oh, that's why I did that. Forgive me, I forgot. I wanted to provide a little better context of what the actual values are, since it was a little bit thrown out of proportion with that large Fruitland observation. So I wanted to dive into this graphic to actually show what the observations are at the individual reservoirs within the Gunnison River Basin. So you can see Fruitland there with that really high number, 1,500% of normal. But then you look at all the other numbers and they're relatively closer to normal. Vuga Reservoir and Silverjack are below normal, well below normal, but everything else is relatively near normal. And then looking at the overall basin as a percent of normal is slightly below when you add up all of those observations, but compared to the long-term trace, we're looking relatively close to normal. We're not looking at some of these lower values that we had prior to this year. Gunnison River Basin stream flow observations are slightly below normal. Again, better in the upper reaches of the basin just because we had better snowpack, and that's still, those stream flows are kind of lingering from the runoff that we had earlier in the year, but things are looking below normal, lower in the basin, unfortunately. Moving to the southwest corner of the state, snowpack not looking very good at this point, unfortunately. You can see that Wiminuche and why am I forgetting the name of that site right now? Vallecito, doing okay for snowpack, but elsewhere, further west you go, snowpack not looking so hot, and hopefully we'll see some improvements there soon. 65% of normal in for the snowpack in the combined Yampa White, or excuse me, San Miguel, Dolores, Animas, San Juans. I think I was going for the shorter of the combined basin names there. But it looks like the precipitation, if you look at what we were seeing earlier on up until about mid-November, things were very bleak. But then the more recent storms that we've had did provide an improvement. So we're thankful for those. And hopefully, as Becky pointed out, we'll see some precipitation focused in the San Juan River Basin, or in the combined San Miguel, Dolores, Animas, San Juan basins, forgive me. And then precipitation year to date in the San Miguel, Dolores, Animas, San Juan is 54% of normal. Reservoir storage is slightly below normal, if I recall correctly. We'll get that number here in a second, but just wanted to show you what the individual reservoirs are reporting as of November 1st. So remember, this data is a little bit older. We'll have some updated data here just after December 1st. And then, yes, as I was mentioning, the combined San Miguel, Dolores, Animas, San Juan basins are showing below normal precipitation, or excuse me, below normal reservoir storage for the combined basin. But compared to what we've seen in previous years, we're doing a good bit better. So thankful for the precipitation and the snowpack that we received earlier this past winter. Stream flows are looking below normal. It was a dry fall and dry summer in the southwestern portion of the San Juans. So unfortunately, those soil moistures are going to be dry. And even if we do have decent snowpack accumulation this year in water year 24, I'm thinking these deficient soil moistures and stream flows will need to be recharged, and will eat up some of that hopeful positive snowpack, high above normal snowpack that we'll have this year. But we will be starting off at a deficit, would be my guess, based on these below normal soil moistures as we go into the winter season here. Moving east into the portions of the Upper Rio Grande Basin. You'd think I wouldn't know what basins I'm talking about here. We've come up with these delineations within the Upper Rio Grande here, and I'm going to trace the Upper Rio Grande here where that exists. So it's this area here. And the reason that we have the colorations on the areas that we do is because of the contributing factors of snowpack in this basin. So if any of you have driven through the San Luis Valley, you know that snowpack really isn't much of a contributor in the bottom of the basin, but in these upper reaches of the basin, the higher elevations feed these sub-basins here. And these are the larger contributors to the hydrograph or stream flows in the basin. And so that's why we're trying not to misrepresent exactly where the snowpack truly accumulates in these basins. So it's definitely in the upper reaches. There are some misrepresentations, some of these areas here and here and here. We really don't see much snowpack in those areas, but based on the HUCs, the hydrologic unit codes and the way that the USGS has them labeled, we've decided to go with this. But nonetheless, what I'm getting at is the majority of the snowpack comes from the upper reaches, the upper elevations of the basins, which we try to represent with these delineations here. So getting into those conditions right now, as Becky mentioned, snowpack is not looking good. Precipitation is not looking good in the San Luis Valley or in the Upper Rio Grande. And you can see that best part is where the majority of the water comes from in this basin, which is the upper headwaters of the Upper Rio Grande, which is here. We are seeing at least a bit better snowpack, but still not great. We would like to see much improved snowpack in this area. And this is where the majority of the runoff comes from. And that's only at 59% of normal right now, where the other sub-basins within the Upper Rio Grande are running well below normal. If it weren't for this last storm that we've had here within the last week, I think it was, we'd have not very good at all. We'd be in the lower 10th percentile for snowpack at this point, but that little storm did give us a boost and improved our situation a little bit to 51% of normal in the Upper Rio Grande Basin for snowpack. Precipitation, pretty much the same story. At least we're not in the bottom 10th percentile. At 61% of normal, the Upper Rio Grande precipitation is better than it was just a week ago, but would like to see some additional precipitation and snowpack accumulation there. Reservoir storage in the Upper Rio Grande is not very good. From this graphic, it looks near about normal. Just pausing on this graphic here for a little bit so you can get an idea of any specific reservoirs that you're looking for. And I'm sorry, I stand corrected. The combined reservoirs for the Upper Rio Grande is above normal. So that's good, especially when you compare it to the last 3 to 4 years. And then observed stream flow, again, below normal. Just been a dry summer, dry fall. Which doesn't bode well for current stream flows and soil moistures going into fall and winter. Okay, the last major basin in the state, the Arkansas River Basin. Snowpack here is okay, but highly diversified. Looking at South Colony, Bendo, and Hayden Pass snowtells. Snowpack has definitely been better here. It's below 50% of normal. We would definitely like to see some accumulations there. In the upper reaches of the basin, fortunately, things are a bit better. We're looking at 67% of normal snowpack in the upper reaches of the Arkansas. But again, still looking for improved information. Oh, you know what? Let me go back. A Pishpa snowtell is typically a snowtell that doesn't hold too much snowpack and can vary greatly. So this time of year, I'm guessing the normal there, or the median number, is somewhere near like a 1/2 inch to 1 inch. If we have 3 inches of water equivalent there, that would, excuse me, my math is off, but that would boost that number to be, over 100 or 200%. So I wouldn't put too much weight here on the Apishpa snowtell showing above normal snowpack. It really doesn't have, unfortunately, big implications on the runoff at this point. So looking at the historical trace for this water year of snowpack, we're looking at 61% of normal in the Arkansas River Basin, again below normal, and we didn't see good snowpack numbers really, except for on November 1 where snowpack was near normal, but unfortunately when it matters, these last few weeks have not showed improved precipitation. Precipitation in the Arkansas since the beginning of the water year is 71% of normal. Just looking for more here. Combined reservoirs in the Arkansas River Basin doing relatively well at above normal. Sorry, I don't have that number right here, but I do have it showing in a later graphic here. When we look at the statewide total numbers, we'll get that number. Again, stream flows in the Arkansas River Basin below normal, looking better, at least at Chalk Creek near Nathrop, but we could definitely use some more snow and precipitation to improve our stream flows, because getting, as I've mentioned before, those below normal stream flows going into winter will suck up any moisture, or any runoff actually will suck up the initial moisture from the runoff when we do have snow melt. Okay, looking at the statewide numbers. So statewide snowpack is 60% of median. You can see some of these larger numbers here, and then some of the individual sites here across the basin or across the state. Like I was mentioning, there are some sites that are showing above normal snowpack, but usually those are the sites that don't typically accumulate that much snow and are really just, in a way, misnomers, I would say. Just be careful. Don't rely on the snowpack from those to show significantly improved runoff. Statewide snowpack, again, 61% of normal. And the trace since November has not been good. November has been quite dry. Highlighting what Becky was mentioning earlier, the above normal precipitation that we saw really in October. We see that target here where we did see some areas of above normal. Really, I wouldn't rest on the green sites. I would look more to the blue sites we did see, but honestly, we're only talking about 111% of normal snowpack, precipitation to this point. A lot of that was lost in October to melt or actual rain. So it's good that we had the precipitation, but it really didn't culminate in snowpack. Here, I'll go back to that snowpack graphic here. Not too much. It's shown a slight benefit to the Gunnison River Basin, but really barely even worth noting. Let's put it that way. Okay, sorry, I hope I'm not making you dizzy. Month-to-date precipitation. This is what I was mentioning kind of earlier. That precipitation that we saw, that targeted area here, was mainly in October and didn't show up in November. November's been quite dry, unfortunately. Yeah, and here again, another depiction that November's been pretty dry. We're just not up to this same slope or trace here. Things have been relatively dry in November. Statewide precipitation is 71% of normal in this graphic. Reservoir storage on September 1st. Just wanted to put this in there just to show you kind of what's changed with reservoir storage in the individual basins, the combined basins here. And then moving on to now, as of November 1st, maybe I shouldn't quite say now, November 1st, statewide reservoir storage is 100% of normal. So that's good. It's also good that reservoir storage is 139% of normal in the upper Rio Grande. And forgive me, I clipped off the sub-basins within the San Miguel, Dolores, Animas, San Juan basins. But so I think it's slightly below normal, as you can kind of see from the coloration here in the San Juan, and then the San Miguel, it looks like it's showing as slightly above normal, at least by the coloration, or near normal. Let me put it that way, by the coloration in the San Miguel Basin. Looking at the statewide trace of combined reservoir storage, fortunately, thankful for this past season snowpack. Reservoir storage right now is right at normal, coming down just a little bit over the course of this past summer due to the drier conditions that we've seen, but fortunate to be near normal at this point thanks to last year's snowpack. And then looking at reservoir storage last year, which is in the light green, and the darker green is this year. So you can see that rise in almost every single basin. I think I should say every single basin, not almost every single one of them since last year. And here's another depiction of reservoir storage and the individual basins. Observed stream flow across the state largely below normal, as I pointed out earlier. Just only looks like the North Platte and the headwaters of the Colorado are showing above normal stream flow as the snowpack begins to build up and codify those soil moistures through the winter. Okay, and finally, to summarize, numbers that I've shown multiple times here, statewide snowpack is at 60% of normal, and then we range from 48% of normal in the Yampa White to 79, near 80% in the Gunnison. At this point in the year, we've typically accumulated about 20% of our snowpack. And at this point in the year, we are at 11% of the annual snowpack peak. So that really kind of goes to lend itself to another mathematical calculation of that 60% of normal that we're showing thereabouts. You know, the numbers change a little bit, but pretty close. So we have a lot to go. So we're going to have to, in order to get back to normal, we're going to need to have above normal snowpack accumulation. At least for the remainder of the year, right? If not, and then hopefully we'll receive it in a few larger storms. Precipitation is at 70% of normal, and fortunately, reservoir storage is 100% of normal at this point in time. And that is all that I have.
Awesome. Thanks, Brian. If anybody has questions for Brian, feel free.
Easy crowd.
Okay. Well, it doesn't seem like there are any. Thanks again, Brian.
Yeah, thank you.
For the update. And I think we can now get into our updates from water providers and water managers. So I will open the floor first to anybody who wants to give an update.
This is Swithin, Centennial Water, Highlands Ranch. We are in good space storage. We're above normal. I would say that's probably due to what Becky showed us with wetter, cooler than summer than normal. So we were able to fill our reservoirs. Customer demand was down, and I guess the summer, it's just basically water year 2023 was good while it lasted.
Agreed. Thank you.
I can jump in. This is Jordan Soldano from Denver Water. Right now, our reservoirs are at about 87% full, and then normal for this time of year would be like 85% full. So looking good on that end. And then we have seen our demands come down to about our winter levels. So yeah, just kind of waiting to see on the snowpack.
Awesome. Thanks, Jordan. Anyone else?
Can you hear me?
Yeah.
Oh, fantastic. Hey, this is Nick Harris with Colorado Springs Utilities. Ours is really an echo of kind of everybody else's, you know, across the board. Reservoir storage is up due to the wet beginning of the year or last year. You know, we saved quite a bit of water in terms of demand, and I don't know that it ever really picked back up. So that really lends to help keeping the storage levels high. But that's really basically all that's going on down here.
Awesome. Thank you. Any West Slope folks want to jump in?
Sure, I can jump in from the San Miguel. I'm Adrian Berger at San Miguel Watershed Coalition. I'm pretty much always unprepared for this question, so I made sure to put something together today. And as I always state, we're not a water provider, we're just a nonprofit watershed group, but in the theme of summarizing water year 2023, I took a look at the NRCS projected runoff at San Miguel near Placerville, and then took a look at actual flows down there. And there's actually like a better array of SNOTEL sites for looking at Placerville instead of looking at the whole basin if you use the Bureau of Reclamation's snow to flow tool. Not sure how many folks are familiar with that, but I really like it. And so for April to July 2023, the projected runoff on the San Miguel at Placerville was 146,000 acre feet. And what we actually got from April through July, the expected was 159,000 acre feet from April through July. And what actually came down the river was 146,000 acre feet. So I took a look at this back in June, I think, and I was honestly expecting more of an error. So there's only 9% difference, which is still significant. It's thousands of acre feet, and our runoff volume isn't huge. So I think decent job forecasting there, but definitely room for improvement. And years prior, there's been much higher error. So pleased to see it was closer. And I think that's pretty good forecast, or the actual runoff observation is pretty reliable because we did not really get much rain during that period. So not super impacted by monsoonal moisture. Thanks.
Thanks, Adrian. Great report out. And yeah, I'll have to check out that snow to flow tool. Anyone else? Okay, I won't call on people today, just because I have a presentation to also do, so I don't want to keep us here for too much longer. Let me just share my screen quick. Okay, 1 second. Okay, are we seeing the slideshow? Yes, can I get a thumbs up?
I see it.
Okay, thanks, Becky. Okay, so yeah, third presentation of this meeting, so I'll try to make it quick. I'll be talking about the state's drought response rebranding from what we all know as the Water Availability Task Force to what will now be called the Water Conditions Monitoring Committee, or WCMC. So let's get into a little bit of background. So every 5 years, Colorado updates its state hazard mitigation plan, which I'll refer to as SHMP. And this plan covers all hazards and related responses. And so prior to 2018, the SHMP had separate but attached plans for flood and then also one for drought. And then in the 2018 update, the flood plan was shortened and folded into the main body of the SHMP. And in this newest version, or newest update of the SHMP, the drought plan will be doing the same thing. So it will be folded into the main body with more clarification in the drought response plan. So this is the drought response framework from 2018, the last time the SHMP was updated. And as you can see, there's the impact task force is down here, along with the WATF in the bottom left right there. And all these groups were technically part of the drought task force, along with the lead agencies in the middle right here. But that's not really how the drought task force practically worked. WATF was never meant to be a part of any drought decision-making body. as the drought task force is. It's, strictly meant to convene and monitor water supply conditions. So as the SHMP was being updated this year, it provided an opportunity to really clarify this framework more to better describe how drought response actually works and how it can be better. So there are 3 changes I want to highlight in the updated SHMP. So first, the thing that's most relevant to us is WATF will be rebranding to WCMC. The phrase task force implies a group that convenes, completes a task, and then disbands. And then that's not how this group really operates. So the new name better captures the role of this group as a body that meets in perpetuity. And importantly here is the goal and structure of this meeting will remain the same. The goal is to share information and monitor water conditions. The only thing that's really changing here is the name. The second change I want to highlight is clarifications for the drought task force. So the drought task force has always practically functioned as being made up of state leadership and staff with input from specialists. And so in this updated SHMP, this is spelled out in plain language. So the main goal of this group is to evaluate drought conditions as they worsen and also coordinate with the governor as needed. And this brings me to my last point, is the impact task forces will be replaced by ad hoc work groups. And the reason for this is because the impact categories were often too rigid and not always effective. So the ad hoc work group is meant to be more adaptive and nimble compared to the impact task forces because they will be able to better respond to specific drought impacts dependent on geography, sector, and issue. And the drought task force has the ability to create these ad hoc work groups. So this figure will be included in the 2024 drought response framework. It's a better representation of, how drought monitoring response actually works, who talks to who. And as you can see, the WCMC is separate from the drought task force. And, this group, we will continue to meet monthly and monitor water supply. And I'll reiterate that the WATF and WCMC will function in the exact same capacity. So if you attend WATF meetings, you are automatically enrolled in WCMC. And so that's just a very broad overview of the changes that will be happening. And that's all that I have for this. And I will open it up to questions, and myself or Kat will hopefully be able to answer any questions that you all have.
Hi, Emily. I have a question.
Yeah.
I think the flow seems to make a lot of sense, especially changing the impact task forces to ad hoc working groups that you can really focus on, kind of what's going on with that specific drought. I'm wondering about the drought task force and how it'll work. Like, if we're going into a bad drought, how I'm assuming this means like the Climate Center or the NRCS would not be a part of the drought task force, but may be called upon by the drought task force. Is that what you envision?
Yes. So the main core of the drought task force is the state leadership. So that's like the director of CWCB, director of DNR, director of other agencies involved. And yes, as you said, our partners like CSU or NRCS will be called upon when needed for specific input.
Okay.
Yeah.
Thank you.
Yeah, of course. Any other questions? Okay, awesome. Well, I think that concludes the last official WATF meeting. I will see you all next year at the WCMC meeting. I hope that you all have a great rest of the year and happy holiday season. So thanks, everyone.
Thanks, Emily.
Thank you.
Yep, thank you all.